Good morning or afternoon, everyone. Thank you for joining today's webinar on using AI to double your test suite for higher ROI. My name is Jamie Motherall, and I'm one of our military and government solution experts at Parasoft. And on the line with us, we have my colleague, Wilhelm Haker.
Hi, my name is Wilhelm. I'm the Director of Solutions Engineering here at Parasoft, focused on our functional solutions, and very excited to show you what we can do with regards to your tests and being able to do more with API testing today.
That's right. We've got a great session planned for you today where we will show you how you can double your test suite with half the effort by using AI to transform your existing web UI tests, regardless of the framework, into API tests and how this will impact your testing ROI. Now, before we dive in, we've got some quick housekeeping. If your view of the slides or the demo appears a little blurry, please be sure to adjust the video resolution in the BrightTalk window in your browser. And it helps if you maximize the presentation to full screen. If you do have any questions or issues, please submit your comments in the Q&A area, and one of our colleagues will reach out to you to assist. All right, let's dive right in. So why do programs adopt web UI testing first? Web UI testing definitely has its place within your test strategy. It's very valuable for things like cross-browser validation, end-to-end validation, client-side logic validation, and of course, user experience validation. Many programs decide to adopt web UI testing because it is very easy for manual and non-technical testers to understand, as it relies on a visual flow of business logic through an application. There are also a lot of tooling options that are record and playback tooling options. So code level knowledge is not required to automate. However, there are definitely some limitations and downsides to web UI testing. Now, a UI test often represents testing a system end to end. While this is very valuable to do, the end-to-end test is the most challenging test to work with in a variety of ways. So let's dive into it. Now, with web UI testing, test cases are notoriously flaky and difficult to stabilize for automation. Combined with the frequency of changes user interfaces undergo, especially in the early phases of development, it is very difficult to maintain automation for functional UI tests. UI tests also take a very long time to run. Browsers are resource heavy. They must render all of the application's content on the screen, and actions for a test case are performed sequentially in the UI. That means that the more actions there are in the test case, the longer it will take for that test case to run. Due to the nature of end-to-end tests, diagnosing failures and performing root cause analysis is very difficult. Is the problem with the front-end code? Is it the application's APIs? Is it the back-end APIs? For contrast, it certainly takes more investigation with web UI testing than it does when you compare it to, for instance, a failing unit test. Now, in most modern development today, applications are becoming more and more complex with microservices architectures, multiple integration points, complex business logic dependent on many data sources. This means that your web UI test will need to increase in its complexity, which will require more time for test setup and more time for test maintenance down the road, which impacts your ability to easily scale your test automation. So let's look for a moment at how this altogether impacts your testing ROI. Each of the four limitations we reviewed has a direct impact on the four most common business drivers we see when adopting test automation, which is increasing your speed, increasing your quality, reducing your risks, and reducing your costs. So let's break it down. As web UI tests are brittle and are easily impacted by your application's change, reliance upon web UI testing will eventually lead to a high test maintenance burden on the team. This results in engineering hours being spent on test maintenance. And as you try to scale your web UI test automation, this problem is only going to increase as your test suite increases in size, eventually requiring you to increase your staffing numbers to keep up with your testing requirements, or delay releases in order to allocate time for test maintenance, or you'll see a reduction in your quality due to less thorough testing of new features due to your lack of engineering bandwidth. As the quality is impacted, this then affects the level of risks associated with your releases, with defects possibly slipping into production. And of course, it increases the cost of fixing defects, as the later a defect is found, the more costly it will be to remediate. Now, when you first are starting out on your test automation journey, the time it takes to execute your web UI tests may not seem to have a heavy impact on your program. However, when your test suite has grown to thousands of test cases, your regression testing is going to take a very long time to execute. This, combined with frequent UI changes, means it takes longer than one would think to run a full regression suite that accounts for maintenance and issues resulting in having to rerun tests that need to be stabilized. This can result in delays to providing the feedback to development, which then impacts the speed of the team and increases your overall project costs. Now, a common downfall for web UI testing is the ping pong that occurs when an issue is found, and the difficulty in replicating that issue in the development environment. As UI testing is mainly looking at the user experience, when an issue is found, it can be difficult to pinpoint the exact location of the bug in the application. This then causes a slowdown, as development must first try to reproduce the issue and identify the cause in order to remediate. This in the end impacts the speed of remediation, which then results in a higher cost of fixing that defect. As applications and websites today become more integrated and more complex, those tests that you need to validate functionality will also grow in their complexity, as well as become more difficult to automate. This leads to challenges in test creation, where each test can take hours to create. Keep in mind, if your team is spending hours upon hours to create tests due to the complexity of the application and use cases, they'll have to spend a lot of time on test maintenance as well. All of this leads to a slowdown in your speed, an increase in your program costs, reductions in quality, and increases in your risks, with possible defects making it to production, as your team struggles to create and maintain test cases for those complex scenarios. Now, in the long run, as your application becomes more complex, over-reliance on web UI testing to test the functionality of the application is just not sustainable, and the overall ROI reduces as your web UI testing suite increases in size. The complexity of your use cases will require more engineering hours and time for each use case, slowing down your test velocity and lowering your overall test coverage, resulting in quality issues, the risk of bugs or defects in production, and then your increase in costs. Okay, now that we have reviewed the reasons programs adopt web UI testing first and the limitations of web UI testing, it's time for an API slide. Why we're talking about API testing has to do with API maturity trends that we see with our customers. Across every industry today, our customers are growing from system APIs to process APIs to experience APIs, and in some cases even open APIs for direct revenue generation. We see API first development as being a hot trend with our customers, and this evolution of API maturity impacts your testing strategy. When speaking to testers, to them, API testing often means testing system APIs or process APIs. These are essential tests to be conducting, but they fall short when an organization's application architecture and API maturity grow to developing experience APIs. Experience APIs are the APIs that your user interfaces are built on top of. Think of an Angular or React web application you're developing. They rely on experience APIs to enrich the user experience. These APIs often go untested and instead are indirectly tested through GUI tests. And that's the real opportunity before us. How to scale regression testing efficiently by looking at how directly testing these experience APIs can pay off compared to indirectly testing them through GUI tests alone. The concept of a lean UI testing approach and focus on API testing for functional validation ties perfectly with the testing pyramid. The testing pyramid was popularized by Martin Fowler and the Agile community. At the base of the pyramid is a foundation of unit tests and API tests. These tests are more efficient, so you have more of them. They can be created earlier in the software development process, helping you to shift left, and are easier to automate, easier to understand, and ultimately easier and faster at diagnosing the root cause of regression and test failures. Automated UI and manual tests need to be focused. From diagnosing test failures on a larger scope of code, to these tests running late cycle, to the maintenance and overhead costs of these tests, they're very hard to scale and get sufficient test coverage from. Of course, these tests do have a purpose and a place within your test strategy where they are very valuable, but you have to be judicious with how many of them you create. Underneath the testing pyramid, where you've shifted further left to where developers are writing code, is the code analysis that helps developers identify security and reliability issues as they're coding and as a part of their continuous integration. Organizations tend to follow the pyramid as a blueprint to help them create a test automation strategy that is scalable. However, in the real world, I often see something different. Many teams identify with an ice cream cone or a goblet rather than a pyramid with more manual or UI tests than API or unit tests. Even in environments where teams are adopting microservices architectures and building experience APIs, I see a lot of cases where their test strategy is still UI top heavy. If this UI top heavy test strategy is something that resonates with you, feel free to put a little comment into the chat for us. Now, because we're talking about system, process, experience, and open APIs, the API testing practice can be an overloaded term. Looking at the testing pyramid, API testing can be split into integration testing and component testing. Experience APIs and process APIs should have test scenarios that validate how those APIs are used in an integrated system. System APIs expose a component's functionality for integration with process APIs and verify that those services comply with their original design, which is an important building block for your test strategy. Let's just take a few minutes here to discuss the benefits of API testing and how shifting from a heavy web UI testing strategy to directly testing your experience APIs can have a positive impact on your overall ROI. For organizations whose API maturity reaches experience APIs or open APIs, API testing can and should play a larger role in driving efficiencies with the test strategy and can have a positive impact on the four primary drivers for test automation adoption: increasing the speed of your delivery, increasing the quality of your software, reducing risks associated to your organization and brand, and reducing your program costs. So let's dig into some of the benefits of API testing and how that impacts your ROI. We discussed a little bit how web UI tests often break due to application changes, which then requires engineering hours to be dedicated each sprint to test maintenance. API tests, though, are closer to the code base. They're more resilient to change, which allows teams to reduce the amount of engineering hours spent on test maintenance and helps them to stabilize their test automation strategy so that it's more scalable. By shifting your testing approach to directly testing your experience APIs versus indirectly testing them with web UI testing, QA teams can instead focus more of their efforts and engineering hours on creating new test cases to cover their new features and functionality. This allows a program to increase the thoroughness of their testing, increasing the quality and reducing late-stage defects that are costly to remediate, as well as reducing the risk of defects making it into their product releases. API tests also run much faster than UI tests, which enables faster regression testing and accelerates the QA team's feedback to development. This allows programs to validate the impact of changes faster on their test suites and application and accelerates the remediation process when defects are actually found. Now, whether the API test is testing experience, process, or system APIs, failures are easier to diagnose with API testing in comparison to DOM to database UI tests because some components of the system will be out of scope of the API tests. And really, that's the trade-off with the benefits of API testing and demonstrates why end-to-end or DOM to database UI tests are still valuable and still do have a place within your testing strategy. The key is how many of those high-cost tests you create that matters. By providing earlier feedback to development and reducing the time it takes to diagnose those test failures, programs can both increase the speed of their testing and remediation efforts and reduce the defect remediation costs. As a result, teams get to spend more time creating new tests and increasing their test coverage, versus spending a large amount of time updating UI tests and dealing with test instability whenever a new version is released from development. This slows down your testing agility. While it can be a cultural shift in adopting a lean web UI testing practice and shifting QA activities to the API layer, it allows you to scale your test automation much more easily and without the typical test maintenance burdens of web UI testing. These benefits allow you to stay on track with your delivery schedule, increasing your speed. It increases the quality of the resulting software and reduces risks associated with lack of test coverage or lack of negative testing. It also reduces the risk of late-stage defects making it into your releases, impacting your brand, and reduces the costs associated with test diagnostics and remediation as defects are found earlier and are easier to pinpoint for remediation purposes. Why isn't everyone API testing if it's so effective? Unfortunately, API testing often has a lot of misconceptions attached to it because it does lie in a gray area between development and QA, where there is some lack of clarity around who owns the testing of the APIs. When speaking with QA engineers, we often hear things like, API test creation is hard, my program doesn't maintain API specifications like Swagger files, development is responsible for API testing, or there's just an overall lack of understanding as to what the APIs are doing under the hood of the application, which for a non-technical tester can be a bit daunting. Now, this is where Parasoft's focus on artificial intelligence and machine learning and test automation comes into play to help bridge the gaps for non-technical testers. Now, I'm going to turn it on over to Wilhelm, who will be walking you through how with our AI and ML solutions, programs can easily convert any of their existing web UI tests, regardless of the framework, into API tests, easily shifting their testing strategy to directly test their experience APIs in order to maximize the ROI of their test strategy and reap the benefits.
Thanks, Jamie. So let's see how it works. Traditionally, when testing through the UI, you're not thinking about how the APIs work or how they're used. The UI already has all the business logic built in that's abstracting those details and orchestrating the sequence of API calls necessary to fulfill the needs of the UI workflows. But when testers need to write API tests against experience APIs directly, they don't know the business logic that the front end was orchestrating. We capture the network traffic while exercising the UI and use AI to build a model of which stateful data needs to be extracted and parameterized so that the sequence of generated API tests will faithfully execute the business logic defined by the UI flow. So we're automatically generating API tests that perform the functions and workflows typically tested through the UI and running them without the UI in the equation. And this has a number of benefits when you think about how slow UI testing can be, both from an execution standpoint and diagnosing failure standpoint. So adopting a lean UI testing practice where business flows can be tested at the API layer ensures that your testing strategy will scale as the complexity of your system grows. Now, many programs have already started their automation journey by focusing on the UI layer. They've invested a lot of time in writing UI test scripts, adopting frameworks like Selenium, Cypress, or Playwright. And with Parasoft's AI capabilities, QA teams can easily convert their existing UI tests into API scenario tests by adding a couple of commands to their test execution scripts. And this works for any web UI test regardless of the framework and allows QA teams to rapidly double their test suite by reusing their existing UI tests to generate these API scenario tests. And so while this works for any web UI test framework, today we've prepared a short demo where we'll leverage an existing Selenium test to create API tests that will in the end run faster than the existing test, be easier to maintain, make scaled progression testing easier, and will accelerate the feedback loop to development, allowing them to more quickly and easily fix any issues that are found. All right, so let's take a look at our demo app today. So this is the Parasoft demo app, and basically this is a logistics application for a camping equipment supplies manufacturer. So we have some categories and items here, and they get sent out to brick and mortar stores where the shelves get filled up. There's an approval process for sending these items out. And so with this web application, this is a Spring Boot application using Angular for the front end. And we can see here in the settings page, this app has been built to be quite flexible in the technologies that it's using. So we could have the front end using REST or GraphQL. Today we'll be looking at REST. There's also messaging systems here, JMS, Kafka, or RabbitMQ. So we can demo various workflows with Parasoft testing tools. So the UI, as we've been talking about, is built on top of APIs. And so if we pop open the developer tools here and say I reload the home page, we can see what calls the front end is making. There's some static content like the HTML, CSS, things like that. But we also have these API calls, right? When we load the home page, the app checks for cart items, but we don't have anything in the cart right now, right? It checks for categories to be able to populate these category page items here, right? And we can see the JSON coming back, and right, this was a simple get call that the web app was making. If we go into one of the categories, right, we'll see some more static content, but then we see cart items again. We see getting regions. So there are different regions in the app. And then, right, getting the items for a specific category ID and seeing the data coming back. And so if one wanted to kind of reverse engineer what a UI test would do, these are the kinds of API calls that you'd have to be stringing together in order to build that whole end-to-end flow. And that can be quite time consuming, right? You could try recording this traffic, but then it's all hard-coded data. And some of the request parameters in various flows are going to be dependent on data from previous API calls. So it's not a trivial exercise to sort of build an end-to-end API scenario test that sort of represents the flows that you're covering through a UI test. But that's what we're here to explore today. And we're going to start off by looking at Selenium here first. Okay, so here I am in the IDE, and I've got a Java Selenium project using page object model. We'll get to this Parasoft recorder class in a moment, but here's the test. We can see we've got a base URL, passing in the Chrome driver, setting up the Chrome driver, and kind of a standard Selenium test for a demo app, adding some things to the cart, going through the order flow, the approval flow. And so what we want to do is inject our Parasoft recorder into the workflow for this Selenium test. So I want to show you how I did that. And so I've got kind of another version of this test class where it's with recorder. So I can show you what I did to kind of integrate the Parasoft recorder REST API with my Selenium test. So a lot of the logic I encapsulated in this Parasoft recorder class. And so we can see for the before test and after test, we've got start recording and set up Chrome driver as a method I'm calling that's going to give me back that Chrome driver with the appropriate options set up. And then after the test is done, I'm going to stop recording and create a test with this name. And so if I was building something out with, maybe there was hundreds or thousands of tests, I might look at a way to parameterize this step, right? For every test that gets run, kind of passing in the test name dynamically here. So why don't we take a quick look at that Parasoft recorder class so I can show you kind of what it's doing. So there's a couple things that we need to account for. So the Parasoft recorder has a REST API endpoint that we want to know. And then where are we sending the traffic? We're sending it to Parasoft SOATest. So SOATest has an endpoint for receiving the traffic that we record when we run our UI test. So during recording, there's a session ID and a proxy port. This gets dynamically set when we start the recording. And so I created a couple constructors here and just passing in the default values with the second constructor. And so if we look at, for example, this first one before we start up the test, I'm doing a number of things here. So checking if sessions are empty so that there isn't another recording session dangling on my local environment. Then I start a new session. And so this is what sets the proxy port and session ID. And then here is where we configure Selenium to tell Chrome to use the proxy that we have where we started our recording session. So If you're using a different UI testing framework, there's going to be sort of another way of doing the same thing, right? Setting the browser's proxy settings. Right, so here we have Chrome options, set proxy, and we're giving back that driver properly configured with the proxy. So that's really how starting recording with the Selenium test works. And I think this is a good example that you could use the Parasoft Recorder REST API with any UI testing tool. Now, if we come to after the test, once we've gone through our flow, so here I've got some actions to stop the session. Here, sending traffic to SOATest with that test name that we have right here. And then ending the recording session. And so these methods that I set up here, they're calling the Recorder REST API. So if we look at one of them, is sessions empty? Basically, we're making a call to this a GET request to the sessions, and we're checking to see if there's a 200, and then here, right, checking to see if the sessions array is empty or not. Right, so kind of basic API calls, right? Starting a new session. This is a post request, so we have some data like the SOATest endpoint that we need to provide. And so I won't go through all of this in detail, but I will later on show you a GitHub repo where I've published this project, so you can take a look at the example code for yourself as well. All right, so now that we've taken a look at sort of how I've integrated the recorder into my test here, let's go ahead and run it. So end-to-end test with recorder. And then we'll see sort of also the full end-to-end flow with this demo app and all the kind of UI steps that it entails. So here we're logging in. We're going to add some things to the cart, and then which store is it going to, some other metadata, now logging in as the approver, make the approval, come back in as the purchaser, and check that the order was approved. So you can imagine through this whole flow, a lot of API calls were getting made. And so, that's what we're interested in, is seeing that test. And so I have some logging statements here telling me everything went well. And we'll look at those tests in a moment. But before we do that, I also wanted to point out, specifically for Java-based Selenium environments, we have a tool called Parasoft Selenic. And what Parasoft Selenic does, it does a number of things. So what I'm going to show you here is essentially the same thing without having to write any code to integrate the recorder. So Selenic will drop into your existing Selenium projects, right? You don't have to modify any code or anything. It's for the IDE. It's built into Eclipse and IntelliJ. And for CI/CD, we integrate with Maven, Gradle, basically instrumenting the JVM that Selenium is running in. And so when we run a Selenium test with the Selenic agent, it makes those API calls to the Parasoft Recorder for us, and it also sends the traffic to SOATest. And so if we look at some of the Selenic options here, this is that option I'm talking about, right? Create API tests with SOATest, and we pass in the SOATest info and the proxy port for the Recorder API. So we can do kind of the same thing without having to write any code. And this is for Java Selenium. Some other things that Selenic does is it has an AI capability to self-heal broken tests. And so as a UI tester, you're probably well familiar with locators needing to be updated, weight conditions needing to be tweaked, and this causing instability in the automation when you run your Selenium tests. So Selenic has some nice features here around stabilizing your tests, making you more efficient, keeping them up to date, as well as recording to create page object model Java Selenium code from the browser. So we have a nice recording workflow as well. But we're not really going to dive too deeply into Selenic other than kind of showing you the same thing here where we're playing back our test and we're going to get an API test here where I'm not using any of the code that I wrote to kind of directly integrate with my project, but rather just running my project like I normally would and using the Selenic plugin, my IDE, to play back my test and get to the same outcome that we did earlier. Right, so same steps again, going in, putting in our data. Approver is going to come in, check the order, approve it, and now we check the status of it. We can see that it was approved. All right, so same workflow, but this time just looking at that vanilla Selenium test that we had. Right, so this end-to-end test here, right, there's nothing about the Parasoft recorder. This is all pure Selenium and JUnit. And Selenic supports TestNG and Cucumber, I should mention as well. All right, so now that we've kind of run our tests, I'm going to switch gears here and come to SOA test. And here we can see, right, two tests were created for us. One of them through the manual integration I made with Selenium to the Parasoft recorder, and the other one that was done automatically by having Parasoft Selenic run my test and do the same thing. And before I forget, let's take a look here. Here I've got my GitHub repo, whawker, that's me. I added my project PDA Selenium Recorder API example here. So you can look at this project as a reference for seeing how you can integrate the Recorder REST API with your test framework. I've also included some links to the Parasoft demo app GitHub and Docker Hub, so you could deploy the demo app locally and try out this project there. You need a Parasoft SOA test license to be able to do this, but if you have one, you could go try this project out. It'll work in your environment with that SOA test license. So coming back to SOA test, I wanted to do a quick intro or orientation for the UI here. On the top left, we have our test case explorer. This is where we'll be reviewing the details of how tests are constructed. In the middle, this is the editor view, which we'll see. The bottom right, test progress when we're running a test. And then bottom left here, quality tasks. So when tests fail, we can see what those failures are and dig in. So before we jump into these tests that got created, I did want to point out that while today's demo is focused on testing experience APIs, SOA test is also heavily used for more well-adopted API testing use cases, like testing your process and system APIs. And SOA test supports a huge range of protocols and message formats, enabling middleware teams and backend teams to effectively automate their API testing. So whether we're dealing with SOAP, EDI, testing legacy systems, maybe we need to FTP a file somewhere, we need to do something with socket connections or fixed length messages. There's a whole lot that SOA test can do to automate these complex test scenarios for those types of systems. We can also run a SQL query, compare data from a database, or maybe you have a NoSQL database like MongoDB. Even asynchronous messaging systems, data streaming, Kafka, RabbitMQ, JMS, IBM MQ, etc. And I should also point out event monitoring, so monitoring the messages through ESBs, middleware platforms, microservice architectures, to help you better test the complex messaging through a distributed system. So there's a whole lot here in SOATest, but as I said today, we're going to kind of focus in on how to efficiently test these experience APIs through this UI recording we've been seeing. All right, and now the moment that we've been waiting for, taking a look at our API scenario test here. So through that end-to-end flow in the browser, we have quite a number of API calls that the browser was making. Right? So logging in, here post request, adding items to the cart, adding a second item to the cart, more stuff the UI was doing, and then here we're placing the order, another post request, logging in as the approval user, making some updates to the order, now logging back in as the original user, and checking the status of the order, marking that it's been reviewed here with this put request. And so just recording the network traffic and hard coding everything is one thing, but what about the dynamic data that would allow you to stitch all these calls together? Like, for example, after logging in as the approval user, we know that there's a put request happening to change the order. And this order number, as you might expect, should be dynamic, right? If the order number was hard-coded, then this test wouldn't make any sense, right? Because we're creating an order earlier in the flow. And so what the AI did for us, and this is really where a lot of the time savings comes in, is it analyzed all the network traffic and it saw, hey, we have an order number here in this put request, and I also see that there's an order number in the response of our post request that's submitting the order, right? And so here in the response, we have this order number. And so what the AI did is it used some of SOATest's built-in tooling. So here we have a JSON databank. You know, I could have added this in manually, but the AI sort of saved me the trouble, create the XPath for me, locating that order number, and sticking it in a variable so that it can be used in a later test step, like here. And so the AI is looking for opportunities where it makes sense to kind of parameterize data, like request parameters, that it sees in previous test steps, and whether it's a request parameter in the URL or whether it's a request parameter in the payload, it's going to parameterize what it thinks needs to be parameterized to make the whole flow of API calls make sense, just like how they would be called by the browser. Some of the things I'll point out before we run this test, the AI is also looking for opportunities to make assertions. So for example, we have some fields here in the order details where, has it been reviewed by the approver or the purchaser? Right, so in earlier test steps, these were false, and then by the end of the test, they're both true. And so when the AI sees that, hey, this response payload, we've seen it before, and this used to be false, but now it's true, maybe that's something important that the tester would want to add a validation for, right, to make sure that it's the correct behavior. And so here, reviewed by purchaser, right, that's sort of what we're doing in this step, checking that field in the response was true. Right, so not only stitching the test together, but also looking for opportunities where data is changing and trying to add assertions for you as well. So really helping the tester save quite a bit of time in being able to build an end-to-end kind of API scenario tests like this. So before I run it, I want to come back to Eclipse for just a second so we can see, all right, when we run the Selenium test, it takes 33 seconds to run. And so one of the reasons why
API testing for your experience APIs can be so valuable to the testing practice is speed. And so if we run this, well, actually, before we run it, let's do one other thing. Let's come in and take a look. So we have 6 orders in the system right now. And let's run this guy. So instead of 33 seconds, all these endpoints got exercised in 1 second, right? We're not downloading the static content. We're not using the resource-heavy browser. We're not rendering images on the page. We're just calling these experience APIs that the browser is calling and making sure that the functionality of the application makes sense, right? So we're not testing cross-browser compatibility. We're not testing the JavaScript that's running in the browser, but we are testing everything else, right? All the functionality that the browser depends on to, have that presentation for the users. All that functionality can be tested via these experience APIs in a fraction of the time. And so if we come back here just to see, did we indeed do it? We sure did. Here's the new order number, the items we added, right? It's in the ending state like we're expecting. So we indeed did run this end-to-end test much more quickly using those experience APIs and testing them directly. Okay, so now that we've got this run, some other things I wanted to point out, right? It's not just about the speed or execution time. There's also a factor of stability here, right? UI DOMs tend to change more often than the API layer. So you're going to be maintaining your Selenium tests more often than you will be the equivalent experience API tests. So maintenance will be lower. Essentially, the bang for your buck on automation will go further before you have to go make edits or modifications. We see that response validations are quite easy. The data that the API is returning, this is the data that's being presented on the screen. So, if we're just testing for functionality, right, we can test at this granular data level, make sure that we're getting the right data that ultimately gets shown in the browser. These tests can be easily data-driven as well. So say we wanted to take this nice end-to-end flow and then kind of loop through it with different data. That's a common use case for this type of workflow is, maybe a single Selenium test through this end-to-end flow, it's not a big deal, right? It's only 33 seconds. But what if I have 50 different data conditions that I want to loop through? I'm going through the same exact pages, I'm clicking the same buttons, but I'm sort of passing in different data and checking that the right things are happening on the UI. So that 33-second test could multiply very quickly into a long time. And so that's where the scaling of, or the efficiency of running those same flows at the API level more quickly really starts to get amplified, right? If we data drive this test with those 50 rows, right, this is going to get done in under a minute versus, 25 minutes. So it can be quite impactful when you think about scale in data driving. Another nice thing about this is now that we've captured kind of a properly configured flow of how all of these endpoints get called by the front end, that means we have a nice setup to come in and start adding other types of tests to this flow. Like, for example, penetration testing. Right? We can do more than just test functionality of our system. We can also start trying to poke holes at these endpoints, right? Making sure that they're behaving in a secure manner. and shifting security left, right? As a DevSecOps initiative, it's a common goal for organizations like, hey, let's try to find security issues early so that by the time we pass through QA certification and we get to the security team, they're going to find less stuff, and that's going to result in less disruption to the release schedule. So being able to reuse these functional tests for security is a great way to enable a QA team, even if they're security novices, to come in and start doing some penetration testing early. And these tests are also well suited for shift left load and performance testing. So one of the modules in Parasoft SOA test is being able to reuse these functional API tests under load and automate that, right? So now not only are you automating functional testing, you're automating security penetration testing and load testing in your early stage pipelines, right? And it's the same kind of story, right? Once you pass QA certification, you get to your performance team where they run those high volume end-to-end performance tests. Well, they're going to find less performance issues also because, right, you caught them early with your shift left performance testing. So there's a lot of benefits that you can get kind of more thoroughly testing the API layer, looking at these experience APIs as an opportunity, right, to get more testing done in an efficient way and earlier in the process. And so, this is how organizations start confidently focusing down how many, what we might call DOM to database UI tests that they create and maintain, while still acknowledging their value and place in the testing strategy, right? We're not saying UI testing is bad and don't do it. I mean, certainly you need to do it. But with Parasoft, you can adopt a lean UI testing strategy that allows for efficiently increasing your test coverage and achieving those continuous testing or in-sprint testing DevOps goals, making the testing pyramid even more practical and approachable to implement. So I know we're getting short on time here. So Jamie, I'll pass it back to you.
Thank you, Wilhelm. That was a great demonstration. With the AI capabilities Parasoft offers, we are truly helping programs to adopt agile best practices by following the testing pyramid. Now, this presentation that Wilhelm just gave was specifically on the top-down approach for creating experience API tests from a UI test. However, it's important to note that Parasoft's solution has a long history of helping testers to efficiently automate process and system API tests as well. Before we wrap up, I do want to reiterate that this is really the direction where modern development is headed. More and more programs are relying on APIs. This information is from a study DevOps Digest did on API usage today. 98% of enterprise leaders agree that APIs are an essential part of an organization's digital transformation. And that is because reliance on APIs ensures for a smoother customer experience, accelerates innovation, increases collaboration amongst development teams, enables more joint development with partners and third-party teams, and it improves the overall developer experience. In summation, when you evaluate the capabilities of each type of testing, you can see the value that API testing brings to your test strategy to fully enable end-to-end testing of your application and enable a scalable and maintainable test automation strategy. While UI testing surely has its value and its place, and it's not going anywhere, in common modern software architectures, the rise of experience APIs opens up a new opportunity for QA teams to maximize the ROI of their functional test strategy with the inclusion of API testing. It also relieves them of costly burdens and challenges that grow due to the increasing complexity of end-to-end test cases, test case setup, and test maintenance. Now, in a few moments, we will reach our Q&A portion of today's presentation. Please be sure to start putting any questions you have into the QA chat if you haven't already. I do want to leave you with these last points as we wrap up today's presentation. API testing up to and including your experience APIs is a valuable component of your test strategy. Overall, it provides a higher ROI than just doing UI testing alone. Shifting to a lean UI test strategy by focusing on API testing provides a more scalable and maintainable test strategy. API testing is a very effective way to ensure quality and increase the thoroughness of your testing. And programs that have heavily invested in web UI testing today can easily shift to API testing by using Parasoft's artificial intelligence-driven solution to reuse their existing web UI test scripts to create complementary API scenario tests that will directly test your experience APIs and help you to maximize the ROI of your test strategy. All right, ladies and gentlemen, thank you so much for your attention today as we went through our webinar on how to double your test suites using AI. As you saw today, we're able to take any of your existing web UI test scripts, regardless of the framework that you're using. And with injecting some commands into your execution, you can use it to connect to the Parasoft SOA test and recorder in order to convert them into API tests, doubling your test suite. Please make sure you put some questions into the chat. It looks like we do have a few, so let me look at these here real quick. Let's see. I saw where you talked about variables being set up. Would the data need to be reset every time to make the test reusable? Wilhelm, do you want to take that?
Sure. Yeah. So when SOTEST is setting up these extractions, right, and parameterizing various request parameters in that end-to-end API flow, that's sort of stitching that one flow together. Now, when we talk about data reset, um, that can depend on the test environment, right? If your test is changing the state of the environment and changing data, there's a number of ways to sort of approach that. The test can be intelligent about what it's extracting. Like, let's say, instead of just picking, an item in an array that's like the first item in the array, maybe parameterizing that XPath, right, to find the right data in the table. I also see when it comes to reusing tests or rerunning tests for regression, using techniques like service virtualization to easily manage test data on the back end, so you can more easily run those tests in a repeatable manner. So I see another question here. I think APIs can be identified with the help of your technical architect of the project. We can certainly use this AI tool as well. Is there a better approach here? Great question, and I think we'd love to sort of talk with you further. So if you want to reach out to us, we can certainly look at what your challenges are around testing, how your teams collaborate with each other today, and talk about where would be the best fit and the best workflows and use cases for Parasoft. With security concerns these days, there is authentication everywhere in production environment. So what are the best practices for authentication in a QA environment to make these AI-generated API tests easy to plug back into the CI flow? The best practices can be at the app or test level. This is a great question, and certainly one that we've seen a lot with our customers implementing the solution.
So in some cases, I see organizations relax the authentication that they do in lower environments. In some cases, they don't. And so, for example, with APIs, OAuth 2 is a very popular authentication mechanism. OAuth has different grant types like client credentials or authorization code flow. And so authentication can be configured and set up in SOA test as well. So, if you record these interactions through a UI test, we can help you configure that API test in an automatic way where it's dealing with the authentication so that when you're playing back the test, those API clients are correctly authenticated, and then the test is going to work, the same way how the browser is authenticating the API calls it's making. You can configure the API test to do the same. Really, really good question, that one. Let's see, I see another question here. Do you also support mobile UI tests like Appium? And yes, absolutely. So some other questions here. Can you share the GitHub link to the project that you shared today? Absolutely. Let me paste that in the announcement box right now. Okay. And another question, my front end depends on GraphQL endpoints. Will this work if it's GraphQL instead of REST? Yes, GraphQL is supported as well. And yeah, I think that's all the questions I'm seeing so far, Jamie.
Okay. Well, really good questions again. Thank you guys for putting those into the chat. We're always happy to have discussions. So if anyone wants to reach on out to us to have a deeper discussion into your testing needs and your goals and how the solution would be a fit for you, feel free to reach on out to us. Again, we're always happy to connect and just have a discussion. I did want to remind everybody, we put in some additional attachments for you as well. So if you do want to learn a little bit more about how Parasoft is utilizing AI today, I recommend downloading our ebook on Guide for AI and Software Testing. We've also added that QR code there that is to the Forrester Wave continuous automation testing platform. Parasoft is always recognized as a leader and an innovator in the industry. And you'll also see that under the attachments, there is a link to the pros and cons of generative AI in software testing, which was a recent webinar we did that you can now watch on demand. We've got some really exciting things coming up for generative AI with Parasoft's tools. So if you're interested in seeing a little bit further how Parasoft is continuing to innovate with the AI story, I would definitely recommend checking out that webinar as well. Thank you everyone for your time. We really appreciate it, and you have a great day. Bye-bye.